Thank you for that, Janice, and it's great to be here. So yeah, good afternoon and good morning, depending on where you are joining us today. I know there's a few of my colleagues back in Australia who have either stayed up all night or are waking up a little bit earlier to join as well. So I appreciate that. So thanks for joining. As per the title, this webinar is about taming the machine for OSP engineering and design success. And this is a culmination of a lot of the lessons we've learned and the insights we've garnered globally from various projects, customers that we've worked with over the past number of years. And it's been a fascinating journey. There's a lot of mistakes we've made. We will continue to make mistakes. And that's all part of really building out this capability for everyone to take advantage of globally. So we're very passionate about trying to connect communities, provide broadband for everyone. So where we can, we take an approach that's very pragmatic, and we try to, let the results do the talking, and really try to help and simplify the end-to-end approach. Because optic fiber networks or networks in general and their deployment can be very complicated. The challenges are complex. So we're conscious of this, and we always are looking to work with organisations to really better understand how we can assist in providing a machine-led approach. So during this webinar, there'll be a number of concepts that I'll go through, and I'm hoping that you'll get some great tips and tricks on starting yourself on the journey or evolving your current journey to a machine-led approach. Some of these I'll go into a little bit more detail, but with respect to the time we have, there'll be a number of, I'm sure, questions that you may have. Please feel free to reach out at any time. And also, we will be at ISE Expo. I'd gladly talk to you then as well. Okay, so let's kick off. So why do we need to embrace a machine-led world? There's many instances and analogies that come to mind when I think of how we, as humans, try to utilize machines. And for most of us, it really starts with, when we first learned to ride a bike. So the purpose of a bike is, for some, just to get between A and B. Others, it's the thrill of going down a very steep slope on a mountain bike and the adrenaline rush you get from that, all the way through to later in our years to learning how to drive a car. And I'm going to reference these analogies throughout this presentation just to try to simplify some of the concepts. So if they don't quite make sense, I apologise. They're the ones that really spring to my mind when I think of these concepts. So when we think about the machine, what is it that really we think about? Well, it can be very powerful. There's typically embedded technology. And this goes everything from, again, the bicycle all the way through, let's say, a racing car. Now, with racing cars, they are super complex. Typically, you need to be a trained race car driver to make best use of this vehicle. You need to really have a great pit crew around you to make sure that everything is running smooth so you can control the machine. So us humans, we obviously have a very different approach to things. We have a cognitive approach, and we balance objective and subjective views, opinions, and we try to marry this up with how we would utilize machines. So whether it be a race car driver, a person riding a bike, pedaling down a main street, racing in the Tour de France, or going down a mountain, it's really important for us to understand how we make best use of this machine to ensure that we're getting the right outcomes. And it goes the same for machine-led design and automation, because ultimately we need to build in the logic that makes sense for them to generate these designs. So it is really critical for us to think about, okay, what elements of what it is that I know, my experience, the guidelines, the rules, what do I have to impart on the machine to make sure that it does the right thing for me and I get ultimately the right result. So as I said, it can be quite complex, and it's up to us collectively to help instill the appropriate rules and guidelines to make it machine-led and retain control of what we're doing. So when we tame the machine, good things happen. And we've got a number of examples of this, but this is one that's recent for us. We've partnered with an organisation called IRBI, and working on a cooperative utility whereby we took the time to standardise the rules for the machine. We collectively tried to understand what type of data we have accessible, how we should use that data, and we created an end-to-end approach to resolving the problem of getting an automated design for approximately 90,000 premises or households in a community. Now, with that approach taken, what we found was from the initial high-level design compared to feasibilities, we saved approximately 10% or $5.5 million. We managed to increase the size of the footprint of the community by 30%, whilst also reducing the total fibre required by 400 miles. So that is, I believe, a very good example of how you can really take advantage of a machine-led approach. You know, this could clearly have been done by humans in a traditional fashion, but it's very hard for a human or humans to take on an area that big and find those sort of savings in a very quick fashion. So in terms of design time, we managed to assist in producing that HLD or high-level design in a matter of weeks, not months. So this is just one example of the human and the machine interface, and when we get it right, we get the rules right, and we work very closely with our partners, we can get these sort of results. So what do we mean by machine-led? So I remember back when I started my career in a tier 1 carrier back in Australia, there was literally a complete floor of CAD or drafts people, and on the other side of that, on the next floor down, were also a number of standing desks where drafts people were physically drawing with pens and paper, and they were doing updates to designs. So that was my first foray into design. Now, for millennials that are on the call today, that may seem like a complete foreign concept, but that's how it was. And I remember clearly that there was this team of CAD people that were at that stage really working with revolutionary technology. They were seen as the skunk works of the time compared to the other team that were doing it traditionally with pen and paper. And it's the same with that sort of evolution and use of technology is akin to us doing, drawing lines in Google Earth or maps versus a different approach. So traditional approaches back then were very manual. We did what we had to do. Many of us, when we studied our degrees in engineering, we learnt how to draw with a pen and paper. That was the way it was done. So things have progressed quite a bit. From there, things have shifted more to software-enhanced approaches, where there's some simple digitization. It's still very tedious. A classic example of this was I remember early in my career I was asked to draw a schematic of the power that was to feed a number of racks in a suite in an exchange or a central office. And I remember having to initially do this in Microsoft Word, which was, if anyone's tried doing that, it is very tedious. So yes, in this instance, my Word document or that schematic that I drew was easier to share because it was digital. We could email it around. It was still a very tedious process. It made it a little bit quicker to generate, but there was still a lot of pitfalls. And the same is true when drawing lines in Google Earth, and how we compare, share our results from doing such drawings is quite challenging. So from there we move to simple automation. And this is everything from straightforward if, then, else type logic, where we put in some logic into our programs to say, okay, if you see this condition, then do this for me, as opposed to you having to physically do it yourself. This also works with local optimization. For example, if we have a network, a street network, and we want to find the cheapest way or the shortest path between 2 points, we can simply put in the logic to find all the different approaches between these 2 points, and then let the machine work out, okay, which one is the shortest, and pick that one and draw that in for me. So that's an example of very simple automation. And in terms of optimization, just on that briefly, the local optimization problem is relatively straightforward because we are typically only looking at a few conditions at most. When we move to the machine-led approach, we're starting to talk about global optimization or global optimality, whereby there are multiple variables, typically across a multi-tiered network, that need to be taken into consideration. So the problem at hand is far greater than the simple approach or the local approach, which means it's very challenging for a human to take all those variables into consideration across those various tiers and consistently produce a compliant design. So that's one of the key differences that I wanted to point out there. So as we move into this machine-led automation and this type of approach, this is really talking about that symbiotic relationship of data, the input data that is used, the people that are going to be reviewing the data, that are going to be running the processes, and ultimately running the machine to produce a design. So as I mentioned, this is really focused around global optimality in a lot of cases, and one of the core elements we try to look at is how can we bring that to bear across the different styles of networks that we're trying to design. Okay, so in terms of some of the key areas we need to look at in order for this machine-led approach to work. The first may seem very straightforward, and everyone's heard this phrase, garbage in, garbage out. And it is absolutely true that the design with respect to a machine-led approach is very much contingent on the quality of data you have. And that quality of data needs to be consistent with what stage of the design process you're at. For instance, if you're doing a high level of feasibility design purely for a costing perspective, the level of accuracy of the data may not have to be that great. You may just focus on getting a street center line for your running line or path versus getting a very specific curbside offset that you would typically see further down the design process when you're going into engineering and make ready, permitting and so forth. So it's very important to understand, okay, what level of accuracy, how good does my data have to be for the specific stage of process that I'm in? The second part of this is standardization. How can I ensure that between various parties in the various stages of this process that I am working to a standard? And this comes in many forms, but in the most simplest form, it's really bedding down a schema that is consistent and is understood by all parties. Once you marry this up with very good data, then you can start getting an increased velocity in your process. And we find that on projects where we've absolutely landed on a schema or a data dictionary of how that data needs to look in and out of a database, for example, or via data repositories, in line with understanding exactly what level of accuracy we need for that stage, then things move very quickly and we can really speed through the design process into a detailed design and eventually construction package generation. So we want to make sure that we source the best data we can, we keep it as standard as possible, and that way we can maintain a far more consistent approach. Because ultimately, in terms of the machine will only do what it can with the data it has. So if we have incorrect expectations, inconsistent data sources, then we will spend more time trying to convert, translate, or transform the data to actually be able to form relationships between one another versus actually getting on with the job of actually designing the network. So a data-driven process can encourage the pack. So this means a few things. One is, again, if we have a standard interoperable approach, then it's going to be easier for us to communicate up and downstream. I heard a great example of interoperability many years ago when I was working on a public safety network. there was a fire chief, and he mentioned that 15 years ago there were instances where two different fire brigades, and this is completely different fire brigades. One was a voluntary based fire brigade, the other was full of full-time firefighters. They would turn up, and because at fires or incidences, and the trucks could not share their hoses because the fittings for the hoses were completely different. This is a classic example of interoperability gone wrong. So obviously in that instance, it's life or death. It's quite critical, albeit in our space, that's typically not the case. It is clear that we can really get tied up in knots and be completely confused if we don't have interoperable schemas. So traditionally, even coming back to that traditional approach, and when with the simple automation or simple digitization, we worked very hard on compatibility. We all had compatible schemas between maybe one or two silos that were directly linked to one another, but it was very hard to then communicate when there was compatibility that was based on a different schema further down or upstream. So with an interoperable schema, this is having the one source of truth up and downstream. And even if there are elements of that data that simply pass through an element of your end-to-end workflow, we feel it's far better than changing or having to transform the data as you move up and down. So again, it's really important to focus on interoperable schemas to allow the machine to really get ahead of steam and move fast. So that is one of the most critical lessons we've learned in a lot of the projects that we've come across or we've worked with over the last few years in particular. And when we haven't really focused hard on that schema, we've ultimately come into strife. And usually what happens first is the machine comes to a grinding halt because the engineers that review the output will look at it and say, hang on, something's not right, it's missing something, can we please review? So it's really important for us to take note of exactly how these things need to be strung together and be open and transparent with these schemas up and down the chain. Okay, so now we're going to see a short video of an example of a machine-led fibre to the home feasibility design. So this, we're hoping to actually do this live, and at ISE Expo, please come by, and we're more than happy to demo this live. But for the sake of this presentation webinar, we thought we'd just record one. So you're about to hear Patrick Edwards, who's one of our consultants, and he really looks after a lot of our customer experience here in the US. He's going to walk through a design. Some of the design is sped up for the sake, again, of the video, but you'll get the gist of exactly how much power the machine can yield and how Pat ensures that the results that he's seeing at the end are in line with his expectations, and that is by ensuring that the data is what is required, and also setting the configuration of the machine with respect to architecture. Okay, so, and at the end of this, by the way, there may be a few second lag, so please bear with us.
And create a new design in Fond, and I'll start by creating a new project. So we're going to do this design in Clinton, Illinois, so I'll just name the project Clinton, Illinois, and choose the first step, which is to choose a network architecture to do the design. So we've got a range of architectures we can choose from here. I'm going to choose a centralized 1:32 split architecture with a 288 fiber cabinet and 8-port sized terminal or closure with a drop length of 750 feet. So that's the maximum distance between an address and the terminal. So an important thing that Fond needs is input data. So it uses addresses, that's where all your customers are, and then it needs either underground path or aerial spans to know where cables can be run to connect the addresses back up to the central office. So you can upload your own addresses or underground path or aerial spans and poles, or you can just use Area Select to pull down data from the database that we have, which has got address data for various parts of the United States, and we're adding to that all the time. So we have data for Clinton, Illinois. So we'll go there. And the first thing we'll do is just draw a polygon. And this is used to pull down all the data from our servers within the boundary of the polygon. We can finish drawing that by just double clicking. Alright, we'll pull on the underground path as well, but you can see that we've pulled in a range of addresses for this area. Oops. And that those addresses line up pretty well with the homes in the area. So before we jump into hitting the Generate Design button, I'm just going to place the central office location as well. And I'll place it fairly centrally, I suppose, over here. So that's where all of the OLTs will be, basically. So now we can hit Generate Design. So the first step in generating the design is to analyze the problem. So it's just all Fond is doing here is looking at where all the customers are and figure out all the different ways that they can be connected. So once it's analysed the problem, it starts to solve it. The first step in solving that problem is to connect all of the closures to the homes. And we can have up to 8 homes connecting to each closure within that range of 750 feet that we set when we chose the architecture in step 1. Once all the closure locations have been determined, Fond starts to connect each of those back to one of those 288 port cabinets. So now all the cabinet locations have been chosen, it's just going to connect each of those back to the central office with the feeder cables or the tier 3 cable. Okay, so the network's now finished. We can have a quick look at it. So I think for the video that I'm making, I'm cutting out a lot of the waiting time that the engine took. So probably took between 5 and 10 minutes to do this design. So what we're seeing here, I'll just turn off some layers. What we're seeing is each address is getting connected back to one of these tier 1 closures, and each of these has got demand associated with it. So this one's got 8 customers connected to it, which is the maximum. And then each of those closures gets connected back to the cabinets that I mentioned, so up to 288 customers, so this cabinet has 273 customers connected back to it. And then finally, each of those cabinets gets connected back to the central office. So that's via this blue cable here. So one thing we might notice in this area is there's a railroad line here, and it's actually being crossed at a couple of points. So what we might want to do is, to prevent that happening, is just edit the underground network, except for that one place where we're happy to have a crossing. So I'm going to go back into the input data section and just quickly click on some of these edges and delete them. So once you've gone through and made all those edits saying basically where you can't cross a railroad, we let Fond just run again to re-solve the network with that new information. And this is an important step. You can basically use this base data again and again. It's this sort of one source of truth that you might want to use for your network. So once we hit Generate Design, that'll go through and regenerate the design just like it did before to create a network with only one rail crossing. Alright, so we can now see that the design has avoided making any of the crossings where we said not to, except for this one spot over here. Alright, and so finally we've got the bill of materials. So it looks at the design and counts up all the different quantities. This is the default one we have, but you can configure it for your own different types of networks. So it'll count all the different cable lengths, different numbers of splitters you've got, and the different enclosure sizes you might have.
Okay, so I hope you enjoyed that. You know, what's interesting when I watch that, and I can never get sick of that process, because ultimately I didn't go to university for 5 years to draw lines, and using something like that, something that can be that powerful. And there's many systems out there, but even watching that go through, you know, I would rather use that any day than trying to manually draw that sort of design, even for that size area. That would just drive me crazy. So you can see that there was a setting of the architecture. There was uploading the data. And what was interesting at the end there was how Pat went through and actually blocked the machine from doing certain things, particularly with respect to that railroad. And this is quite important to note. So again, the design or the machine can only do what it can with the data it has. And in that instance, there was no input file that talked to railroads. However, if there is a separate file that can be input, that is, for instance, railroads or major roads or other natural blockers to a network being constructed, then by all means, these data sets can be input into the process before the design even commences to save that step. And we use this logic quite regularly when it comes to reviewing designs and doing a final iteration of designs after a construction write-out, whereby a crew will take the design out, they'll write it out, and they will say, hang on, there is a natural prohibitor to a design coming down this street. So they will provide a layer for us that blocks or restrains the network for a path going down that direction. And we then, that can be then input into the next stage of design process to produce a valid and constructible design, which is obviously the end point. Okay, so what's important to also think about here is, how does this all relate to the various personas or the different types of people involved in end-to-end networks? And really, it all starts with dreamers. These are communities that strive to be connected. They're the ones that, really want broadband. They want to be served. These are typically cities, communities, and, what's fascinating is talking, moving around the States and being at certain conferences and hearing these stories of community leaders that are talking about the fact that their schools are only 60% served, and 80% of the kids that live outside of school are completely underserved. So those stories, really provide us with fuel to try to solve these challenges and to try to find ways to help these sort of communities. So, these dreams are really important because they inspire us to act and to take the right approaches and take the right steps. Even though these steps are often hard and challenging, I feel as part of this telco industry, it's on us to lead the way and find solutions. So we need to think really hard about these dreamers. The next are the dream weavers, and these are advisors, consultants, suppliers that support these dreamers. They will find ways to take the initial skeleton of a want or a dream from these dreamers, and then start putting meat on the bone, so to speak. They will help fleshing out exactly how we could potentially get there and provide this connectivity, this critical connectivity to these communities. So what's interesting is there's obviously a lot of subjectivity in this space. There's a lot of opinion. What's critical is that by using a machine-led approach, we try our best to eliminate a lot of that subjectivity. We try to keep it as objective as possible. And when we build this logic, this is really looking at all the objective views, requirements, and guidelines that force a certain approach or certain things to be adhered. That is all machine-led versus the human saying, well, actually, I would prefer if this is done this way, with not too many real facts supporting that claim. So it's quite important to think about, okay, what does this mean for each of these constituents? Next, we have the dream keepers. So these are the organisations that hold the keys to getting these networks built. And these are typically munis, governments, PPPs, ILEX and CLEX. And these organisations obviously have a lot of understanding, or great understanding, experience. They try very hard to create the appropriate footprints to make them work, make them feasible. So again, it's really important to think about how can we instill the right approach, how do we configure the right processes as we shift through and use the data, and from the initial phases, what's important to each one of these personas as we move through the process to hopefully eventually actually configuring networks and making them absolutely for the betterment of these organisations and communities. And then we have the dream architects. So these are those that know exactly how this all comes together. They know the technical ins and outs, and they have the appropriate level of detailed understanding to really bring this whole thing together. So eventually when this network is built, it actually works and it serves the purpose. So engineers, end-to-end OEMs, distributors. And we find that more and more we're working with these types of, these dream architects because they're starting to see the benefits of a machine-led approach. They're starting to really ask really hard questions of their own processes, the way they've been doing things to date, how could they potentially speed things up. So it's really fascinating for us to work with, for example, OEMs where, optic fiber manufacturers saying, hey, maybe there's a way we can have our equipment set preloaded for others just to make the use of, and we could save a lot of time and hassle in the end-to-end process by having that preloaded somehow. So there's each one of these personas has a lot of work yet to be done, and it's really important, again, that we as a community in this space work together to try to bridge the gap to eventually help these underserved areas. So here's a few tips and tricks. Firstly, we need to digitize as much as we can. We need to make sure that everything we're putting together is put together in such a fashion that we can collaborate with others, that we can share with others, and it's accessible. There's no point in having something that is really just sticks with one person that can't be shared, because then there's typically rework, and often it just leads to a lot of confusion. So we try to digitize as much as we can, and that means everything from digitizing the rules all the way through to the way that we digitize data. And it's still fascinating how on projects today there's a lot of pen and paper out in the field, and that's fine. There's ways that we're starting to see organisations evolve and starting to move to more digital methods. And even if initially it's a very simple approach of using image processing or image recognition to transition that into something that's digital, that may be enough for that phase of the project or that phase of the end-to-end process. But digitization is critical. Using old school hand-drawn designs is very tough. Machine can't really make too much of that to be able to really get the right velocity in the end-to-end approach. Standardize. So as I said earlier, it's really important to work on the interoperable schemas. We want to have that one schema that rules them all across the end-to-end, and this ensures that we're communicating about the right things at the right time. And if we're consistent across our SMEs, our partners, we really get great velocity in the end-to-end process. And we don't get these choke points of data or choke points of rules that really actually contradict each other. And we see that quite regularly, unfortunately, whereby there are two different planning organisations or two different planning teams in larger organisations that have slightly different views of a certain rule or guideline. And ultimately what that means is that it's very tough to take into consideration exactly what they're trying to achieve out of this. And we typically find ourselves stuck in the middle saying, actually, you said it was 8 ports, 4, you said it was 6, which one is it? Because this is about really being objective and providing the machine with the right rules to make the right decisions. So if, statements like should it be about this much or could be about this much doesn't really help in the long run when trying to stand up a machine-led approach. It needs to be very fact-based and saying, okay, this is exactly what it is. These are the decision points. A great example of this recently was we were involved in a project where the vault sizing, or pits as we call them back in Australia, was led by one side of the organisation, and the logic was if the size of the enclosure is this and you're at X% full, then you need to upgrade that enclosure. Now there was another part of the organisation that said actually that's not quite true, it's about this. What this meant was that our rule set was continuously getting bounced, and it just led to a lot of delay, and ultimately it almost stopped that part of the process. So it's really important to standardise the rules, and know exactly what you're trying to say to get that speed through the process. Collaborate. So as I've been saying, and I'm sure you've picked up on, this is a team effort. There's no one organisation or one person that knows everything. So we need to work collectively to make this work. We need to ensure that we understand each other, we're transparent with how these things need to come together, what the data actually is supposed to be, what it means, what schemas are we trying to adhere to, what does the architecture need to be, up and down that chain, so we can really assist one another in getting there. And even in terms of the way we share designs, there are ways now to collaborate on designs. That doesn't mean you have to take screenshots and then post into emails. That's another very tedious process that I'm sure many have done in the past. So we need to move away from that and find better ways, more streamlined, to collaborate on our designs. And finally, simplify. This is something that is obviously one of the hardest things to do, and it's particularly when we are dealing with complex problems. So we always try to distill down the complexity into things that really matter, and that may mean that we really focus on 80–85% versus getting to 100% on some of these things. It's really important to be pragmatic on how how this all stitches together. So I would recommend that, when working with your teammates, with other organisations, try to think of the core elements that are mandatory versus those that are nice to have versus those that are highly desirable when thinking about a machine-led approach. And you will get there a lot sooner. So, as I said earlier, being an engineer, I find it very tedious to draw lines. And I think it's very important for us to start thinking about how we can get away from manually doing designs, how we can get away from drawing, using red line markups physically in front of us in the office, and really focus on how we can shift to a machine-led approach. And it can be a little bit scary, it can be a bit of a change process, but it's absolutely worth it. And I think we all owe it to our communities that we serve to take on this approach. So thank you for listening in. I hope that was useful. We will be at ISE Expo. Please come by. I recently moved to Denver, so I'm very excited that it'll be my hometown expo. Please come by. We will also have a presentation called the 7 Deadly Sins of FTTX Engineering, which we got a lot of great feedback from when we presented this a little while ago. So I look forward to seeing you guys there. So thank you again.